Alright, Miss Schuessler, what if it doesn't approach the same number every single time from the left and from the right? Well, there are things called one-sided limits, so let's look at the graph below, and we notice that the function does not approach the same y value as x approaches c from the left and the right sides. That means that the general limit as x approaches c of f of x does not exist in this particular moment. Sometimes we are only interested in what's approaching from the right or from the left, and we can say that using the following notation. So we can say the limit as f of x as x approaches c from the right, that little plus sign right there indicates I am coming in from the right, is L, and then my limit of f of x as x approaches c from the left, again, that little minus sign this time now indicates I am coming in from the left, is equal to k. Now we can say that the limit of a function as x approaches any number c exists if and only if the limit as x approaches c from the right is equal to the limit as x approaches c from the left. Using the notation, we have this, which says, hey, the limit of f of x as x approaches c exists if and only if, which is normally I abbreviate that if and only if, but technically the real shorthand are those two arrows. The limit as x approaches c from the right of f of x is equal to the limit of f of x as x approaches c from the left. Alright, so that is the shorthand version of that. Going to our next example, let's explore this a little bit. So the first thing we gotta do is graph this mess. So let's pause this. Let's graph. Alright. So graphing this first piece, I start to plug in 2, but 2 is not included, but I still want to know approximately where my graph starts. So plugging in 2, I should have gotten 5 minus 4, which gave me that 1. And from there, I see that my slope for this is -2, so down 2 over 1. Alright, so now I'm going to go graph my other piece. Alright, didn't quite make this graph big enough because my y value at 2 for this graph, if I plug in 2, I should get 7. And then from there, I know it has to be less than 2, so I'm actually going to go down 3, back 1, down 3, back 1, so that way, if I read my graph from right to left, my slope should be right 1, up 3. Depending on how you guys learn slope, so done part A. Now let's go find the limit looking from the right. So from the right, meaning this away, from the right, as I approach 2 from the right, it is approaching this number 1. Alright, so now let's go ahead and we are going to go from the left. Let's see if it approaches the same number. Well, from the left means, hey, I'm approaching from the left, which should be this piece of graph. And from the left, I am approaching that number 7. Alright, so what can we say about the limit as x approaches 2 in general? Well, since 1 does not equal 7, we can't say that that limit exists. So that's what we call does not exist, which this is pretty common notation among mathematicians. And it is okay on the AP test.